Okay, guys, we'll start. Uh, good evening, everyone. I'm sharing my screen. Already started the recording. Share. Okay. Okay, we'll go to our data factory. So first, I'll copy two tables to my storage account. We'll work on those two tables for today. So I said 22. We are discussing data flows, right? So Daynuts input data. I'll make a folder for today. Fine. I'll say name as joins or I'll say EMP data is the folder name. Okay. Upload to files. I'll share you both the files. Just a sec. Employee data one and department data one. Open. Upload. So in employee data one, what do we have? Edit. Preview. We have same thing: employee ID, name, salary, joining date, manager ID, location, department ID. Okay, we have department ID 123 123 123 departments. Okay, and in department data we have department ID and department name. So it can fetch these values from here. So we have two different tables. Last time we had everything on one table only. Now we have two different tables. Okay, so yep. So everyone who knows SQL or kind of stuff, fine, but I just wanted to repeat some concepts. Okay, so we have something called joins. Whenever we have data in two different tables, if we want to combine this data or make use of data from two different tables or two different locations, we have something called joins, the concept of joins. If you want to understand what joins are, just go to Google and say joins in SQL. We'll say joins in SQL only. I'll show images. Nice. Okay. So these are kinds of joins. Consider there are two tables A and B. So A is a table, B is a table. So when you are saying the names of joins, there are no names in this image. So okay, this is left join and right join. I'll just go to the image itself. Okay, there are two tables A and B. Consider two tables. If you say left join, what happens is there is some data which is common to both these tables, like common column, like what we had here. I'll open these tables only, our two tables. Let me open. We had employee data one, right? So in employee data one, we have department ID. We have employee ID, name, salary, joining date, manager ID, location, department ID. And in department data, we have only department data. I'll show. So only department name. So what are the common columns for these two tables? So this is table one, say this is table two. Okay, what I'll do is for this purpose, I'll just copy this so that you can watch both of them at the same place. I'll put it here for now. It will not work, but let it be here. Okay, so these are two tables. This is one table, this is another table. As same shown in the figure, this is table A, this is table B. Fine. So when you're talking about left join, what left join means is you will get all the data from left join and take the corresponding data from table B. You take all the data from left table A and corresponding data from table B. So how does it work? So when you say left join, this is my left table, this is my right table, this is my table A, table B. If I say left join, all this data will come and these joins are based on the common column which is present in both these tables. Here the common column is department ID, same department ID is there. So, okay, when you're matching based on this common column, when you say left join, you will get all of this left table, and you will get corresponding values from right table. Corresponding values means for every value of this department ID, here what do you have for one? You have HR. For two, what do you have? IT. Here for three, you have finance. So when you say left join table A, left join table B, when you're left joining these two tables, all these values, corresponding values will come here. It will repeat, like for every value of one, you will get HR here. For every value of two, you will get IT here. For every value of three, you will get finance here. This department name, you will get an additional column which says department name. So it will match both these columns, department ID column, it will match, and based on the matching, it will get the data here. This is how it will get the left join. We will have all the data from the left table and corresponding values from here. If there is some value called 4 here, and say some department called marketing, that will not come here because there is no 4 value in this department ID. Okay, so that 4 marketing will not come here. Only left table and corresponding values picked up from the right table. That's what happens when we are doing a left join. The same way when you say right join, uh, when you say right join, what happens? You will get all the values of right table. 1, 2, 3. Then what happens is for every 1, 2, 3, there are so many values from the left table, right? All will get repeated. So it will say one HR, 2 IT finance. For one corresponding, this row is there. This row will come again for this 2 and IT. This row will come again for 3 and finance. This row will come again, and again for one HR you will get a new row, and again one HR we have this data here for one. This row will come for again 2. Like what are all the corresponding values from left table, that will all come to the right table here. And in right table, since we are having this 4 and marketing as extra, this will also remain on the right join, right? When you say right join, you'll have all the values from right join and corresponding values that to be fetched from the left join, from the left table. Okay. So here, the extra value which is not matching is for marketing, that will be there when you're doing right join. If you have some value here, like say 131, bingo, salary 75,000, say same 2018, 203, NY, say department 5. So when you say department 5, this value will not come because this is not corresponding to any of the values in this department ID. This is extra value here. This is the odd value here. This is the odd value here. When you are doing right join, all these values will come here. 1, 2, 3, 1, 2, 3 will come because these are matched by these 1, 2, 3 values. And 4 also will be there in the right table because you're doing right join. For left join, what will happen? All the values of left table will be there. Corresponding values from right table will come here. When you're joining two tables. Okay. When you're joining two tables, you will have all the columns. Even if the columns are repeated, you will have all the columns. Like when you're joining these two tables, we'll see in practical. I just wanted to clear it before it comes. Okay. So see, when you're joining two tables, you'll get a new table in this format. You have all these columns from left table. Then you have same again these control C, and you'll have same columns from right table again. You'll have department ID both the times. Two times you'll get, so that you can understand corresponding what is matching and all. So you'll get a new table when you say left join or right join, new table in this format. So you understood how the values will be corresponding and coming, right? So that is left join and right join. When you come to inner join, when you say inner join, only common values will come, no other extra values will come. So when you consider inner join, when you see our example, all these 1, 2, 3 values from this left table will come. All these 1, 2, 3 values from right table will come. What will not come? This row from left table will not come. This row from right table will not come because this is a odd value. Got it? So that's how It works for inner join. When I say inner join, all common values from this, all common values from this will come and join a new table as per this. Now we got what is left join, we got what is right join, what is inner join, right? When you say full join, all values will from A table will come, all values from B table will come, and all the corresponding values also will be matched. Okay, means we'll get all the common values like inner join, we'll get all these values till here. We'll do this practically again on data factory only. These values, all these values will come, then these all values will come, then again this odd man out value will come because it's a full join. Then again this value will also come because it's a full join. Even when it is not matched, those values will come on the left table and the corresponding right values would be blank. When right values are there, the corresponding left table values would be blank. Okay, that's how when it comes for full join. There is something called left outer join and right outer join. Okay. Uh, when you say left outer join, it is named as left join excluding inner join. The name is basically, when we use it in data engineering, it is called left outer join. When you say left outer or left anti join, you can call it left anti join. When you say left anti join, the common values will not also come. The B table will also not come. Only the A table, which are not in common, those will remain here. So what are those values here in left anti join? Only this value which is not corresponding and which is extra on this left table. Only this value will be there when you say left anti-join. I'm talking about left anti-join. When you call right anti-join, what would come? Only this value which is not corresponding to table A would come on right anti-join. Got me? So we will have, so in data engineering, in data factory or data bricks, we would be having only joins with left. We don't have right join, right anti-join, or something like that. Only thing is, uh, based on what table you use on the left, you can use the logic like if you want to have right join in data factory, in Databricks or in Python, what you use is you put the B on left side and use it as left join only. That's the difference. When we use it, you'll understand. Or else, this is left join, this is right join, this is full join, this is inner join, this is left anti join, right anti join. So we don't come across full outer join or excluding inner join anywhere. So whenever you want to combine two tables or work on joins and get data from two tables, if you're not understanding the logic, what I'll do is I'll just open up a joins image in Google so that I'll easily understand what left outer join is, what left join is, what right join is, what in what combinations, if I use what joins, what data I'll get would be more easier. Okay, whenever you're learning from basics, just open up the join. Nothing wrong in just looking at the images. Just open up the joins image. You'll understand. Okay, what join A has, what table A has, what table B has, what comes in this intersection, what is common in this, what will come, what will not come, you'll understand this. If you have this in mind, it is good, or else you just open up on your Google and you'll understand very easily about joins when you're building new tables. So joins is one concept where you're combining two tables. Okay, when you have more than two tables, if you want to combine, what you'll do is first join two tables, then you'll get one large table, right? With that, you join the third table. As simple as that. Okay, so it becomes one table and that will be second table. So again, two tables only, you will do the same operation. That is simple. Okay, we have something called union in this. Union is nothing but more than two tables also. Whenever the all the columns are same, you could do a union. Union is nothing but similar tables you have with similar schema or similar structure. If there is table with this 130 column data is there, no? If you have same table, I mean with same column names and all, if you have another table, you can union these two tables. What will happen is two tables will get joined one after the other. That is called union. Okay, so we got that also. Fine. So now we'll go to. So any doubts now? I just wanted to clear before going applying the same things on data factory. If you want me to explain something, some join again, we can do it. I'll show you how since we are using the same data there, if we after performing join, what all values will come. It will be easy for we to understand, for us to understand. We'll move. Okay. Okay, I'll create a new data flow where we'll be having to, I'll create data sets first, which will point at my two tables. So these are CSV files only where I am having my data. So Azure Data Lake Gen 2, then select the CSV file, continue. Here I use the existing link service only. Here I will say this data set, EMP data set, just to remember. So input data, which folder? EMP data folder. I have EMP data one.csv. I am selecting this. I am creating a data set. I'll publish. There's nothing to change on this. I'll create another data set, new data set, Azure Data Log Storage, CSV file. Here I'll say department data set. Here same link service I can use because the link service is pointing at that storage account only. As simple as that. Input data, employee data, department data. I say publish, this is getting published. Ah, see. Here we have our two data sets. Now we'll go and build the data flow. Data flow. So this time we'll be having two data sources, right? Till yesterday, last class, we only had one data source. We had applied everything on one data source. Now we have two data sources. One data source would be our first data set, second would be our second data set. So one add source. So here I select this data set which I have created, which is EMP data set. Okay, allow schema drift. We'll discuss in this moving forward, schema drift and validate schema. We'll switch on this data flow debug so that we can preview the data. So we created one data set, one source. We'll create another source. Another source would be our department data set, right? So allow schema drift, we can choose. So we got both our source one, source two. Here it is employee is there on top of one, bottom one it is department. Yes, is debug. Okay, what we'll do is we can add a join here. Something join. We have a join, right? When you say one and you say plus, we have join at the top only. Okay, when you say join. So when you come to the join, whatever you have to define, here it is asking for the name for this join. Nice description you can give. It is asking what is on the left stream, what is on the right stream. The same way we discussed what is on the left side, what is on the right side. Left stream, right stream, the same thing. So our left stream is source one, this one. Our right stream is source two. So we have left employee table, right department table. Here we can choose between the join, which join you are doing and combining the files. If you say inner join, only the common values come. Okay, so inner join, and we have the conditions to declare. Condition means we have to join these two tables on which column. We have to call, we have one common column, right? We have to specify that common column. When we say department ID department ID is equal to, you can, the condition is there when department ID equal to department ID, basing on this condition, join these two as inner join. Inner join means only common values will come. Okay, then let this debug go. We can preview the data and see how inner join came and what it is showing up there. Here we whatever I said about left anti and right anti, here we don't have that. Those you can see in Databricks. When we go to Databricks, right there we'll do left anti join, right anti join. That we'll understand. I'll tell you a nice use case also. Just we'll complete this. I'll tell you nice use case for left anti join because you'll be using it on like very frequently. Data flow debug. Come on. So projection. This joining date. Date specify format. It's still debug is running. Here date is not there. Join. Yeah, this is ready. We'll go to data preview and refresh. So we have selected inner join, no? So what our values are coming, we'll see.
Shashank, every time we have to define this data types, or it will take automatic, or every time we have to do that.
Data types, here this projection,
Yeah, a projection.
it is not automatically detecting that date value. That's why I was doing. You can just come here, see
Mhm.
projection and see, or come to data preview here, see if everything is coming all right. You can go forward with it. Only if you are not getting something all right, go to projection and check and set something. Normally, it will detect, see, everything. Data Factory or Databricks also, it has some inbuilt features to detect the data type. It will do based on that only. Okay, if you see that something is not right, you go and you set it. So this is my date value is in what format? That's what. YYMMDD, it is in this format. Or else you can import projection also. Yeah, so we got all our data. Just a second, guys. Okay, what we'll do is to understand the, what are the outlier values. I'll edit the source data only because only common data are there, like 123, 123. That is the same thing is coming when I did the inner join. Department ID, go to join. If I see data preview, transformation stream is invalid. Click to see errors. Close. Wait. In this projection, department ID, let's 123 only. Specify format or we'll make it integer. Come to second one, projection, department ID, make it integer. Now we go to join data preview, refresh. Yeah. Now we got matched and we got our data. department ID, same corresponding values we got, and department names and all, we got the data, right? So what happens is when we are reading from CSV file, everything is read as string only. That's why when you see here and see projection, if you're not importing the projection, it will not understanding anything, and it is just giving us all string values only. I say import projection, then it will see what type of data it is there and give the this. Then if you have an issue, you can just change it. Department ID, I change it to integer. Here also I change it to integer, and now it is able to match. In join, what did we set? It should match based on department ID and department ID, right? So based on these two, inner join, we got the common values. So these data did not have extra values. No, we did not have the extra values so that we can understand left join and right join. What we'll do is one not is 3. We'll add some more values here. 131 bingo 1000. We'll put same date y203 comma ny only comma department 4 which is not on the right table, and I'll say save. Same way I'll go to department table. Here also I'll add some data so that we'll get. Here I'll put 5 value and say this is marketing. Say save. Okay, when we come here and refresh data preview, it should load along from the whole source, and it should give me. Now I got all my inner values. When we have inner join, now if I say left outer join or left join or left outer join is same, I should get all the values from left table and corresponding values from right table. Means I should get this value from left table, including this value of this department 4, department ID 4, this bingo also I should get. Okay, so that's what we'll check. We'll say data preview, left outer join, refresh. Got all the values, and we got 131 also bingo, where it does not have corresponding values on the right table. So we got nulls there, right? Since it is left outer join, we'll get all the values from left table and common values also. So we got the common values also, department ID, department name. Since there are no matching values from the right table, we got it as null. So the same way we'll check for right outer join, and we'll do a data preview. So here is join is just an operation on the two tables. After doing this operation, you can add a sync so the data will be written there. We'll add a sync and write there also. So here, see, for all the department ID 1 values, corresponding values from left table got populated. All the, for all two number department ID, all the values from left table got populated. All three also came. For 5, there is no corresponding value on the left tables, but we have an entry called department number 5 and marketing, which I have added just now, right? So for that, there is nothing there. So all the values from right table have come, corresponding values from left table have also come. Since it does not have a corresponding value on left table, it is null. Okay, we got the inner left outer, right outer. When you say full outer join, it will get all values from left table, all values from right table also. And wherever there is no corresponding values, there it will show blank. Let's see. It will show null. So for this 131 bingo value, right table, there is no corresponding values, it is showing null. For this 5 department marketing, there is no corresponding value on left table, it is showing nulls. Okay, so that's what the joins, how the joins work. If anybody was already working on SQL, this might look lame, but we need to understand for anyone who has not worked on SQL or anything. So that full outer join, inner join, left outer join, right outer join. Here we not having the left anti or right anti join. So I'll just explain that because it is important. Same, I'll create an Excel again. We'll or else we'll go to the same sheet.
One more thing, like here we can only join two tables or more than two tables also.
That's what we can join more than two tables, but one after the other we can do it. First, join two tables, create a third table, then join that larger table to the next table. That would be easier.
Okay.
Yeah, that would be logic also. I wanted to talk about left-hand join, right? So left-hand join, I'll take an example and how it is used daily. So you have some record, like the same thing. We have one, two, three, four, five records. The date is 05. These records are from say today's date 050505. Say this is some sales transaction or something. You bought a mobile or something. Say mobile something else something else something else. So this is date. Okay, I just gave fifth. Okay, then this is one table. Then we have same data coming. We have a full data coming in the next. This is sales data of fifth. Okay, up to fifth. I mean this is sales data up to fifth. Consider it as sales data up to fifth date. Now we'll get sales data, complete data up to sixth date. Means what we'll get? We'll get this data also. Then corresponding to this, we'll have more values where the transactions happened on sixth. Right. So this is the sales data that is still sixth. This is complete sales. Above is complete sales data. So that is it. Look. Now what I need is every time while doing data engineering, while I'm getting a source from my data, uh, I'll be pulling like give me data for last 1 month or last 1 week daily because I don't want to miss any data. You can have that first day you get this data after the data other than this only new data only you can get. But what I'll do generally do is get data for say last 1 month or say last 1 week so that data may come twice, but I don't want to miss any data. There may be data updating late. Today's data may be updated tomorrow. There is some issue, some latency kind of thing. So I'll be getting data one for 1 month or last 1 week. Then I'll be getting this repeat data, right? So today's data, I'll got these five records. Tomorrow I'll get these five records also for fifth data and sixth data records also I'll get. Then, but when I'm getting this, I am putting this temporarily some temporary location, but I don't want to copy all this data and replace this. It is a waste of my processing also because here I have given only five records. These may be 5 million records also, and these may be 8 million records. If only new data is 3 million records, that would be easy for me, right? I don't want to process all 8 million records and replace my new database or new table. I want only 3 million records. First, what I'll do then, I have this already. Yesterday, I have this data now. I got this data now. What I have to do basically, if you see these two tables, you understand that from this has to be minus, right? You have to from if you call this table B, this is table A. B minus A you have to do. Then you'll get all the six values, right? So the same way, if you say this is table A, this is table B, you can do join on this. So how do you do join on this? You do join on date only, or you do join on this serial number. What A join B, what join you will do? What I'll do is B join A, and I'll say left anti-join. When I say B left anti-join, what happens is whatever records are not there in A table, whatever records are new in the B table will come. Means this 8 million minus 5 million, I'll get my whatever needed is 3 million records I'll get. Anyway, this table has all the data from past also, right? When I say left anti, whatever it is, whatever is new on B table, that will come. All the table which is already matching with A table will not come. Only when I say left anti, left table, whatever is there, it will leave off corresponding. It will leave off. It will not consider A. If there are more values also, A it will not consider. Only the new values which is coming from B, that will come. So that is a use case. Daily, day in, day out, when we are doing when we say incremental data, sometimes we use this logic also. Most of the times it is like I got the data till some timestamp, say 7:30. I'll note this timestamp, and data coming after this 7:30, I'll take as incremental data. Incremental data is nothing but you got some 1 million records. Only the new records other than that should be saved in our database. All that again repetition data should not come. That is what incremental data means. You have to upload or process incrementally means you will only process new ones. Basically, they use timestamp. But I told you the issue, right? Just to avoid any missing data, I'll get data from past 1 week or past 1 month. Even if the data is repeating, I'll get this. I'll place this in some temporary table. Like I said, temporary table I space this, and I do an left anti join here with B, left anti join A, so that all the records which are new only, I'll get it, and I'll do the processing on these new records. That's how we use left anti join. Here we don't have left anti join on data flow, but we use in Python, in PySpark, while doing Databricks, we'll again do the same one, and we'll check how left hand join is advantageous. Okay, so this is join. This is joins. These are different joins. Here you perform joins on two tables. You create a join. You saw the data preview. Then what you do? You add a sync here. Normally, you sync and you create a new data set. If already data set is created, you can use that. You are creating a new data set, right, in the form of CSV file. What link service you want to use, same link service, but I want to write in the folder of output data folder. Okay, I'm writing in output data folder. I'll see the data preview. Okay, we got the full join, right? So full join means all values came from left table, right table, everything came, and we are writing it to our location. We have selected the data set also here, right? Now we publish this, the whole data flow is saved. How we run this? We select a data flow activity from a pipeline, and then we'll run it. Then only the data will flow. Only here we are just looking at the data preview. As the name suggests, it is just a preview so that we understand what is actually happening. Everything is done correctly or not. If you really want to move the data, you create the data flow 3, go to pipelines, create a pipeline. In that, have a data flow activity. In that data flow activity, you point this data flow, and then you run this. And then when you run this activity, the actual data will flow from the source to table to CSV files to the destination, that CSV file, new CSV file. Only data flow, if we create and publish, the data won't flow. It is just a setup. We have to run this data flow from a pipeline. I'm just running it. If anyone is stuck while you're practicing, you can ping me on WhatsApp. I can connect you. And if you're really, you don't want to ping me, or say if you're working somewhere in the midnight and you want to clear something, just use ChatGPT. Most of you, if you are really working, already working professionals, will be using ChatGPT or Copilot. It will help you a lot. For each, just tell it that I am using Azure Data Factory. I am building a data flow. Give it a context and say, I am trying to build a data flow. I am stuck with this. My input is this, and clearly explain everything. It will give you the solution. You can build big data factory pipelines also just with the help of ChatGPT. It will tell you step by step what to do, what data set to correct, whatever to see and all. You can build pipelines with that also. Solutions, you can get it there. Input data, storage container, output data. This is a file that came here, 5th 943. Just now select this file. I did not specify a name. So this is my data. All data came here, right? So all this with blank values also it came. This is the marketing. Okay, so this is how you call a data from a pipeline. You need to create a data flow activity here, then only you can run. That is just a setup there that we created a data flow. Okay, let it publish. We'll move to the next one. So that's how we do joins between two tables. Okay, so we have nothing on something called so we'll create a new data flow. What's this add source? I am adding a source, same source. I'll have this first data set where EMP is there, employee data set, projection, import projection. Let it run. What I have is something called window. So, if people who know SQL understand what is window function group by over and all, we'll see what window does here. So, window, what actually it does is, we'll open this. We have this data here, right, on the left. Okay. A window is nothing but it will create small windows out of this data only. Say we have if we are saying window of department ID, what it will do is it will group these uh, into different groups based on department ID. Or if we say on manager ID, it will group by manager ID and do operations on that group. Okay, so that is window. When you use window is when you want to rank these values or rows based on that window, you will use window function. Okay, so here if I want to group these, we can just see what we'll do is just we'll just apply a filter or a sort by data headers, sort by department ID if I say. So it has sorted, right? So this is one window. If we are saying window to be created on department ID, all this is one window. And you can sort on this window or make ranks on this window. Or the same way, if you are creating a window on department ID, this is a second window. So these will come under one window or one block. You can do sorting or rank these rows based on this window. We'll do the same here and see. So source column, window on which column to? I'll say department ID only. So what do you want me to do? Do you want me to sort? Okay, you sort by what? You sort by name, ascending values in sort. Don't want any window columns. I don't need to give a column, I guess. Only if I am doing a function, we'll see in data preview. See errors. One window column. Okay. Okay. I'll say functions. I'll say sort, right? So if you want rank, you can create dense rank. Dense rank is nothing but it will create rank based on this, based on that window, and it will rank your items. It will rank your rows. We'll say rank by name only so that it will rank by alphabetical order here. When you say dense rank using the function dense rank and say input schema as name, we'll see what will show. Type mismatch, okay. Department ID sort by Windows column. say preview, we'll see. So in department, okay, what I did was in sort, we specified that to as it has to sort this based on name and ascending, right? That's why it was not taking my name as parameter in this dense rank again. So what it has done is in this window, say window of department ID 1, it has sorted my name, my values in the form of in by sort by name, and given the ranks to these things. Department ID 1. So you can call this as, since you're applying dense rank, you can call this as rank data preview and say refresh. Okay, so in window of department ID 1, it has sorted every row in order in an alphabetical order, and it have given ranks. So what you mean by dense ranking, in a particular window, it will rank from 1 to 10. And again in the next window, which is window of department ID 2, it has ranked from again 1 to 10. Again in the window of 3, it has recorded 1 to 10. And again in window of 4, there is only one value. Say, then there is only one rank. Okay. We can do this on over department ID also, or we can do this on manager ID also. If you say manager ID, they are somewhere around 3 rows in each manage ID. So you can sort by name only, range same, Windows column also, rank only. If you see preview, you should get 1, 2, 3, 1, 2, 3, 1, 2, 3 rankings in each managed ID value. For each managed ID value, there are somewhere around 3 values, 3 rows. So for 201, okay, for 201 there are 11 rows under 201 managed ready. So in that it has sorted by name and it had given ranks as 1, 2, 3, 4, 5 up to 11. On 202 there are 10, and for 203 there are 10 again. So that's how we do it on Windows. So you have to specify the window in over, and then we have to sort. You can say ascending also or descending also, or you can say name only, and by salary also you can sort. Okay, if you do by manager ID and say sort by salary, descending, highest salary will get rank 1 in that window of that particular manager ID. Okay, so here we specify rank 1 only, and we go to refresh and see. So by salary descending, it has for 201 manager ID, Zach has the highest salary, so it got rank 1. Then Quinn has 69,000, second highest 2. Walt has 69,000. So these two got the second place. So when you say dense rank, it is like our IIT or MSET ranks. You get a number of rank ones, rank twos with same value. 69,000 same salary, right? So these two got 1, 2, 2, then 3, then do fours, 5, 5, 6, 7, 8. So same values will get same ranks. It is what dense rank here. Okay. And it is done in a window. So this is Windows function and dense rank. This also you'll use somewhere when needed. What when you want to group by date and get the latest one, then you can do by group by date the same date value, and if you want the latest one, rank it by timestamp it has in use cases, then you'll get the latest one in for all days. If you want the latest record for all days, or the if you want highest sale for a particular date, for every day what is the highest date, if you want, you'll be making a window on each date and get the highest sale record. Here we got for every manager ID we got a window in that highest salary person we got here, Zach. So next again here highest one was Dan with 74,000. So you can, the real time use case would be that if you want a highest sale in every day's data, then whole data you'll take, create windows based on date, and descending order you'll say highest sale price or the transaction, and if you find the rank, the first rank would be the highest sale of each day. That is a real time use case for this window and rank. So that is window. Okay, I'll remove window. Let the source be the same. Okay, here what I'll do is I'll add a select. Select we have already discussed, right? I'll just want to do a operation where I want to remove this employee ID. I want to have name, joining date, manager, manager ID also, location, department ID also I want to remove. What I want is I have something operation called surrogate key here. If you have surrogate key uh, being applied on this, if you are having data without any serial number on something, the surrogate key what it will do is it will assign key values to all the records. You just add the surrogate key application here. Incoming stream is select one, key column value, key column required is name of the key column. What you want, you can have same employee ID only. And you can declare from what number it should start. Start value should be 101. Step value is 1 means after 101, 102 will come, 103 will come, 104 will come. The same thing we'll see in the data preview. Here what will say is start value and step value it is asking me. Okay. So whenever you have records without any primary key or serial numbers, you can use this surrogate key application create these, right? We got employee it's 101, 102, 103. If we have the step value as say 5, you'll have 101, then 106, then 111, something like that. We'll check for that also. So which step of 5 we got it, right? 101, 106, 111, 116, the same thing. If you want to create some key value for all the rows, you can use the surrogate key. Okay, fine. This is surrogate key. Then we have something called, okay. What I'll do is I'll add another source again and add source, my department set, projection, import projection. Here also projection is imported, right? Fine. Then here I have something called exists. Let's see how to use this. My left stream, okay. My left stream is source one. I have to define the right stream first. Right stream would be source two. I got it right. So it will give me value same as joins only. Here it will tell me it will check my values in source one. If the same values is present in the source two only, it will give the output. Or else it will not give. There are two options here for exist here. Exist and doesn't exist. Okay. When I say exist, it will give the common values. If you see the diagram here, it is this showing, right? It is the common values between these two, source one and source two. Okay, so I can give the same thing. I have used department ID and department ID here. It will match between department IDs and it will give me the common values for source one and two. This exists means what it means is whatever the department IDs are present in source one, it will check whether the values are existing in source two or not, and it will match those and give these values. So if I go to data preview, it will show you the data. So it gave only all 1, 2, 3 values because 1, 2, 3 values are present in right. It will check only, it is not giving me right values, it not giving me right table values. It will only give me left table values. But what it does is it will check whether the department ID 1, 2, 3 are there in right side or not. So if you go here, if you say doesn't exist, I should get my bingo value. We created a new record, right, which is not common to this left and right table. Just a second, guys. Okay, if I say doesn't exist, what happens is in left source column, it will see what is not in the right source column and it will give me only left source values. Okay, I'll go to data preview and refresh. So I got my bingo value, right? So whatever I have discussed, this left anti that we can use here in this doesn't exist because it is only giving values from the left table which are not existing on the right table. Okay, so that is what exist operation is used. Exist between two tables. Exist means it will give me common values. Doesn't exist means it will give me only the values on left table which are not on right table. So that is like same like my left anti which I have discussed. I have discussed left anti, right? So that can be used with this exist not exist. Okay, that is my exist not exist. Then same way we have something called lookup. Uh, Try this. Primary stream is this. Lookup stream is source to match on any row. Match on any row. Any row. Okay. This is department ID. This is department ID. This is basically used if you are searching for one value in the right thing. If you say only first row, it'll check for okay. Left source one column, source two column, sort conditions. Okay, it is if you say first row, it'll asking whether to sort the second source and then check or not. Okay, we'll so this any row only. Then it'll look up and give the same value here. Nothing different, but some use cases you can use this. So when you in Excel also there is something called lookup. So it will do join between two tables only. It will look up the second values and get those values here. So here also it is giving the same. Is looking up in the second thing and getting the values for one HR two three three writing right. We'll change some options and see first row source to column is department source to department ID ascending. Only first row means we'll see what will happen. Nulls first. Okay, refresh. Something different happened. What is this? 1 2 3 2 1 3. I think we'll find a difference if there are more values on department ID and department name table. If we have more values, then we'll be easy to understand this. I'll come to this tomorrow or else I'll check what's happening here. Because lookup normally it is looking up for same values, but here in last row and first row there is some issue. We'll come back to this or else what will have okay. There is something called union, right? So uh, A union can be done between two tables which are of same format. Like I have like said that union, if you have one table with employee ID same this columns, right? If you have second table with same employee ID name, salary, jointed, manager, and location name, then you can union these two tables. So it will be like appended, both of them one after the other. It will be just attached in the bottom. It is like append. Okay, so that union you can do if we have a same table with same format. What we'll do is here only we'll say employee data one. We'll rename and we'll say union. So two times. Okay, this will close. Close. Don't save. Close. Don't save. Try again. Okay, employee data with this. We'll upload the same file again with a different name, no? So we can perform a union on both employee 1 and employee 2 because they're of same structure, same schema and all. We can do a union. This is employee data. Employee data 1 is there. We'll upload employee data 2. Go here. This lookup, right? When we have union also the same way. Union also will ask union between source 1 union with source 2. If you say here source is department, but I don't have department, right? I want my employee 2. So I'll create a new data set because I have no data set which is pointing at employee 2. Just now I have uploaded, right? So I'll create a new data set here itself which will point at employee 2 table, employee 2 file. Okay, so projection, port projection, preview. When I say union, it is asking for incoming stream source 1, then union with what? With source 2, right? So I want to union by name or position. See, if both my tables are same, if I say with name, same name columns should come under same name columns. If I say positions, different name columns will come and different name positions. So I'll put name only and see data preview. We'll see. Generally, union you will not use logically only if you and only if you want to combine some similar tables and all. Here you got right same tables 101 to 130. You got 131. Our bingo is there here. Again from 101 to 130 we got. So same tables you can union. Generally, whenever you do union, it's not like joins that you don't know the data, you can make a join and find out. In unions, you'll understand that the same schema is there, same names are there, then only you'll do the union. It is blindly, it will attach the second table under the first table. So you should be careful. Fine, that is what union is. Okay. Okay, it needs some sync so that I can save this.
So Shashank, whenever we have to save this as a file, we have to use sync. Okay.
Yeah. Since the data flow, right, it will ask for both source and sync, or else it will not get published, it will not get saved.
Okay. It is like a commit.
Yeah, if you want to commit, it is asking where to write this also. Since the name itself suggests data flow, right? It should
Yeah.
flow and reach something, or else it will not save. If you want to save something, add some sync and save, so that let's see. Only for just for checking the data applications, we can use this data preview, but or else we'll have sync only.
Okay.
Okay, so that's it. Any doubts in today's class, guys? joins, left anti, we got some use case. From next class, what I'll do is just learning these building blocks is like a bit dry, I guess. I'll take use cases. If anything new we are learning in that use case, that day I'll will learn that new item and we'll proceed with use cases. Or else with existing all building blocks what we have learned, we'll do the use cases. I have somewhere around 30 to 40 use cases scenarios. We'll do all of those from next class. In that we'll use all different. We'll learn new activities also as a part of that. We'll get data from on-premise data. We'll get data from Webflow. We'll find a nice website and get data from there and then do transformations. I have 30 to 40 use cases. We'll solve each of them. So just learning this building blocks one by one is kind of like a textbook structure. I don't want to go by this enough. Go with use case, solve it. If something has to learn, we'll learn that building block and then again solve that use case. Fine, guys. Any doubts in today's class? This is just basic only. If you are already working on SQL and joins, then it is just 2 GB for you here today. Okay, then okay. Whenever you are working, if you have something about joins, just like I said, just open Google, just bring out a joins image, then everything is clear. You'll understand what is A, what is B, what is inner, what is left outer, or what is left anti, or what is right outer, right anti. You'll get the idea easily. Got it? We don't have anything. I'll wait. They wanted who are attending classes. I'll just note down your names. Whoever is there here today. Gauss, you are good. Everything going good?
Yes, I'm paying everything.
Fine, right? If you have anything, you can ping me or ask me.
Yeah, okay.
Yeah. Okay, guys, then I am ending the session today. From next class, we'll do use cases only. We'll come with use cases. And if anything activities are to be learned newly, then we'll add this use this activity, learn that activity, and solve this use case. That would be better, I guess. Or else this is like I am also getting bored of uh, doing all small activities. Fine, guys. Tata, good night.
Okay, sir.
If you have
Thank you.
anything, you can ping me on WhatsApp. I'll take some time. I'll take time, but I'll connect. Nice. Okay. Stop.